What if the solar system itself was artificially arranged as a giant experiment? What if I told you that everything you've ever known about our solar system, the way the planets orbit, their precise distances, the seemingly perfect conditions that allow life to exist on Earth? What if all of that wasn't an accident of cosmic evolution, but the result of deliberate design? What if we're living inside the universe's greatest science experiment, and we don't even know it? I'm your host, and welcome to another episode of Javis Heist, where we explore the mysteries that challenge everything we think we know about reality. Today, we're diving into one of the most mind-bending possibilities that some scientists, philosophers, and researchers have quietly been discussing for decades. The idea that our solar system itself might be artificially arranged. Now, before you think I've gone completely off the deep end, I want you to consider something. When you really look at the mathematical precision of our solar system, when you examine the almost impossible coincidences that had to occur for life to exist here, when you study the patterns that seem too perfect to be random, well, it starts to make you wonder, are we looking at the greatest accident in the universe, or the greatest experiment? Picture this. You're standing in your backyard on a clear night, looking up at the stars. Above you, 8 planets are dancing in their eternal waltz around the sun, each one maintaining its distance with clockwork precision. Earth sits in what scientists call the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist. But here's what's truly staggering. The margin for error is impossibly small. If Earth were just 5% closer to the Sun, we'd be Venusa's hellish wasteland with surface temperatures hot enough to melt lead. If we were 15% farther away, we'd be a frozen ball of ice like Mars. The fact that we exist in this narrow band of habitability is already remarkable enough, but that's just the beginning. Let me paint you a picture of just how precise our cosmic neighborhood really island. Our moon, that pale companion that lights our nights, is exactly the right size and distance to create perfect solar eclipses. When the moon passes between Earth and the Sun, it covers the Sun's bright disk almost exactly, revealing the Sun's corona in a breathtaking display that has inspired and mystified humans for millennia. Here's the thing that keeps astronomers up at night. This is an incredible coincidence. The moon is about 400 times smaller than the Sun, but it's also about 400 times closer to Earth. This creates what's called an apparent size match that shouldn't exist by pure chance. In fact, this phenomenon is so rare that in all our observations of thousands of exoplanets and their moons, we've never found another system where this occurs. Now, let's talk about Jupiter, our solar system's gentle giant. At first glance, Jupiter might seem like just another planet, albeit a massive one. But when you dig deeper into what Jupiter actually does for our solar system, things get interesting in a hurry. Jupiter acts as what scientists call a cosmic vacuum cleaner. Its massive gravitational pull, more than twice that of all other planets, combined sweeps up asteroids, comets, and other space debris that would otherwise rain down on the inner planets. Without Jupiter, Earth would be bombarded by potentially civilization-ending impacts every few million years instead of every few 100 million years. But here's where it gets weird. Jupiter is positioned at exactly the right distance from the Sun to maximize this protective effect while minimizing disruption to Earth's orbit. Computer simulations show that if Jupiter were significantly closer or farther from the Sun, or if it were much larger or smaller, the delicate gravitational balance that protects Earth would collapse. Think about that for a moment. we have a massive planet positioned with surgical precision to act as our solar system's bodyguard. Some researchers have started calling this the Jupiter shield theory, the idea that Jupiter's position and mass were specifically chosen to create a safe harbor for life to evolve on Earth. In 1766, a German astronomer named Johann Daniel Titius discovered something that would puzzle scientists for centuries. He found that the distances of the planets from the Sun followed a mathematical pattern so precise that it seemed almost impossibly deliberate. This pattern, later refined by Johann Elert Bode, became known as Bode's law. Here's how it works. Start with the sequence 0, 3, 6, 12, 24, 48, 96, 192, where each number after 3 is double the previous number. Add 4 to each number, then divide by 10. What you get is 0.4, 0.7, 1, 1.6, 2.8, 5.2, 10, 19.6. These numbers correspond almost exactly to the actual distances of the planets from the Sun, measured in astronomical units. Mercury, 0.39, AU predicted 0.4. Venus, 0.7, 2 AU predicted 0.7. Earth, 1 AU predicted 1. Mars, 1.52, AU predicted 1.6. Asteroid belt, 2.8, AU predicted 2.8. Jupiter, 5.2, AU predicted 5.2. Saturn, 9.54, AU predicted 10. Uranus, 19.2, AU predicted 19.6. The accuracy is startling. And remember, this pattern was discovered before Uranus was even known to exist. When Uranus was finally found, it fit the pattern perfectly. The pattern even predicted the location of the asteroid belt between Mars and Jupiter. What are the odds that 8 major celestial bodies would arrange themselves according to a mathematical formula by pure chance? Astronomers have struggled to explain Bode's law for over 250 years. Some dismiss it as coincidence, but others wonder if it might be evidence of intelligent design on a cosmic scale. Then there are the orbital resonances, the way planets' orbital periods relate to each other in precise mathematical ratios. Jupiter and Saturn, for example, have orbital periods in a near-perfect 2:5 ratio. Jupiter takes about 12 years to orbit the Sun. Saturn takes about 30 years, almost exactly 2.5 times longer. These resonances exist throughout the solar system, creating a cosmic symphony where planets dance to mathematical rhythms that seem far too organized to be random. As we zoom out and look at our solar system as a whole, we encounter what cosmologists call the fine-tuning problem. This refers to the observation that the fundamental constants and conditions of our universe, and by extension, our solar system, appear to be precisely calibrated to allow for the existence of complex chemistry, stable stars, and ultimately, life. Consider our Sunday. It's a G-type main sequence star, which means it burns hydrogen at just the right rate to provide stable, long-lasting energy. About 90% of all stars in our galaxy are either too hot and burn out too quickly, or too cool and don't provide enough energy for life. Our Sun falls into the narrow range that can sustain life for billions of years. The Sun's position in our galaxy is also remarkably fortuitous. We're located in what astronomers call the galactic habitable zone, far enough from the galaxy's chaotic center to avoid deadly radiation and gravitational disruptions, but not so far out that we lack the heavy elements necessary for rocky planets and organic chemistry. Even our solar system's age seems perfectly timed. We formed about 4.6 billion years ago, when the galaxy had undergone enough stellar cycles to create the heavy elements we needed, but not so recently that we'd be bombarded by the high-energy events that characterize younger galactic neighborhoods. In 2000, paleontologist Peter Ward and astrobiologist Donald Brownlee published a book called Rare Earth, which argued that Earth-like conditions might be far more unusual than we previously thought. Their research suggested that the combination of factors necessary for complex life is so specific that Earth might be one of a kind in our galaxy or possibly the entire universe. But here's what's fascinating. As they cataloged all the requirements for Earth-like life, the list became so long and so specific that it started to look less like a series of fortunate accidents and more like a carefully crafted recipe. You need a star of exactly the right type and age. You need a planet of exactly the right mass to hold an atmosphere but not become a gas giant. You need a large moon to stabilize the planet's axial tilt. You need a magnetic field to deflect solar wind. You need plate tectonics to regulate climate. You need a Jupiter-sized planet in exactly the right position to clear out dangerous debris. The list goes on and on. Each requirement, by itself, might be reasonably common. But when you multiply the probabilities together, when you calculate the odds of all these factors occurring simultaneously in the same system, the numbers become almost incomprehensibly small. Some researchers have calculated that the probability of all Earth's life-friendly conditions occurring by chance is less than 1 in a trillion. Others put the odds even lower. At what point do we stop calling something a coincidence and start looking for other explanations? Now, I want to be clear about something. When we talk about the possibility that our solar system might be artificially arranged, we're not necessarily talking about little green men with flying saucers. The intelligence capable of arranging planets and moons would be so far beyond human comprehension that we probably couldn't even recognize it if we encountered it directly. But that said, there's an intriguing connection between the solar system experiment hypothesis and ancient astronaut theories that have captured popular imagination for decades. Ancient texts from cultures around the world contain surprisingly detailed astronomical knowledge that seems far beyond what should have been possible with the technology of the time. The Sumerian tablets, for instance, describe our solar system with remarkable accuracy, including planets that weren't officially discovered by modern astronomy until the 18th and 19th centuries. The Maya developed calendars of extraordinary precision and tracked planetary cycles with mathematical accuracy that rivals modern astronomy. Ancient Hindu texts describe cosmic cycles spanning billions of years and contain detailed descriptions of planetary motions that align closely with modern calculations. The builders of Stonehenge somehow knew how to create a structure that perfectly tracks solar and lunar cycles over vast periods of time. Could these ancient peoples have had help? Could the same intelligence that arranged our solar system have also provided guidance to early human civilizations, ensuring that knowledge of the cosmic experiment would be preserved for future generations to discover? There's another angle to consider here, one that's gained serious attention from philosophers and physicists in recent years: the simulation hypothesis. Proposed by philosopher Nick Bostrom in 2003, this idea suggests that our entire reality might be a computer simulation run by some advanced civilization. If that sounds like science fiction, consider that some of the world's leading thinkers take this possibility seriously. Elon Musk has stated that he believes the odds we're living in a base reality are billions to one against. Theoretical physicist John Wheeler proposed that reality might be fundamentally informational, that the universe is made of bits rather than matter and energy. Now, here's where this connects to our solar system experiment hypothesis. If we are living in a simulation, then the incredible fine-tuning we observe wouldn't be the result of impossible coincidences or divine intervention. It would be the result of intelligent programming. The mathematical relationships, the perfect positioning of planets, the precise conditions for life, all of it could be the result of cosmic code designed to create the optimal environment for whatever experiment is being conducted. Think about it. If you were running a simulation to study the development of intelligent life, wouldn't you want to create the most stable, protected environment possible? Wouldn't you position a Jupiter-like planet to act as a shield? Wouldn't you fine-tune the orbital mechanics to ensure long-term stability? Wouldn't you calibrate everything to maximize the chances of your subjects surviving long enough to become interesting? If our solar system really is an artificial arrangement, there should be evidence. The question is, what kind of evidence, and where should we look for it? Some researchers suggest we should look for patterns that are too perfect to be natural. The mathematical relationships we've already discussed, Bode's law, orbital resonances, the precise positioning of planets might be smoking guns. Natural systems tend to be messy, irregular, and chaotic. Artificial systems tend to be ordered, predictable, and mathematically elegant. Others suggest we should look for what they call cosmic signatures, evidence of large-scale engineering or manipulation. This might include anomalies in planetary compositions, unusual isotope ratios that suggest artificial origin, or structures that seem to serve no natural purpose but might be part of some vast mechanism. There's also the possibility of finding what researchers call maintenance artifacts, evidence that someone or something is actively managing our solar system to keep it functioning properly. This could include unexplained course corrections in planetary orbits, mysterious adjustments to solar output, or the sudden appearance or disappearance of space objects in ways that serve to protect Earth. Some scientists are even looking at the possibility that certain asteroids or comets might not be natural objects at all, but rather artificial constructs designed to look natural while serving specific functions in the larger experiment. Here's something that's always bothered me about our search for extraterrestrial life. If the universe is as vast and old as we believe, and if life is as common as many scientists think it should be, then where is everybody? This question, known as the Fermi paradox, has puzzled researchers for decades. But what if the answer is simpler than we thought? What if we're not seeing signs of other civilizations because we're living in a protected laboratory environment, deliberately isolated from the rest of the cosmic community? Think about it from the perspective of a scientist studying animal behavior. When you want to observe natural behaviors, you don't interfere with your subjects. You observe from a distance, making sure they can't detect your presence, because you know that awareness of being watched would change their behavior. If Earth is part of a vast experiment studying the development of intelligence and civilization, then the experimenters would have every reason to keep us isolated from other intelligent life. Contact with advanced alien civilizations would fundamentally alter the trajectory of human development, contaminating the experimental results. This would explain not only the Fermi paradox, but also why our solar system seems so perfectly designed for life. We're not seeing evidence of other civilizations because we're meant to develop in isolation, in a carefully controlled environment designed to maximize our chances of survival and growth. Now, you might think that ideas like these are purely speculative, relegated to the fringes of scientific thought, but you'd be surprised how many mainstream scientists are taking these possibilities seriously. NASA's Kepler Space Telescope has discovered thousands of exoplanets, and the more we learn about other solar systems, the more unusual ours appears to be. Most planetary systems we've observed are chaotic, with planets in highly elliptical orbits, giant planets very close to their stars, and overall configurations that would make life extremely difficult or impossible. Our solar system, by contrast, is remarkably orderly and stable. The planets orbit in nearly perfect circles, all in the same plane, with spacing that follows mathematical patterns. It's becoming increasingly clear that solar systems like ours are rare, possibly extremely rare. The SETI Institute, while primarily focused on detecting radio signals from alien civilizations, has also begun investigating what they call technosignatures, evidence of large-scale engineering projects by advanced civilizations. This includes looking for structures like Dyson spheres around distant stars, but it could also include evidence of planetary engineering or solar system manipulation. Some researchers are even using artificial intelligence to analyze astronomical data, looking for patterns that might indicate artificial arrangement or ongoing management of planetary systems. The AI systems are designed to detect anomalies that human researchers might miss, patterns that are too subtle or complex for us to notice, but which might reveal the hidden hand of cosmic engineers. If our solar system really is an artificial arrangement, the philosophical implications are staggering. It would mean that everything we think we know about our place in the universe is wrong. We wouldn't be the result of random cosmic evolution, but rather the products of intelligent design on an unimaginable scale. But it also raises profound questions about free will, consciousness, and the nature of reality itself. If we're part of an experiment, do we have genuine free will? Or are our choices somehow constrained or influenced by our cosmic experimenters? Are we truly conscious, or are we sophisticated simulations designed to behave as if we were conscious? And what happens when the experiment is over? Are we destined to be studied until we reach some predetermined endpoint, at which point the experiment concludes? Or are we meant to eventually transcend our laboratory environment, perhaps becoming cosmic experimenters ourselves? These questions might seem abstract, but they have real implications for how we understand our purpose and our future as a species. Now, in the interest of fairness, I need to acknowledge that there are compelling natural explanations for many of the phenomena we've discussed. Most mainstream astronomers and physicists believe that the apparent fine-tuning of our solar system can be explained without invoking artificial intelligence or cosmic experiments. The anthropic principle, for instance, suggests that we observe a universe fine-tuned for life simply because we exist to observe it. In a multiverse containing countless different physical realities, we would naturally find ourselves in one of the rare universes where life is possible, because we couldn't exist in any of the others. Regarding Bode's law, some scientists argue that it's more of a curiosity than a mystery. The law doesn't work perfectly for all planets, and it completely fails to predict the positions of Neptune and the dwarf planets. Some researchers suggest that any sequence of objects will eventually appear to follow some kind of mathematical pattern if you look hard enough. The orbital resonances that seem so precise might simply be the result of gravitational interactions over billions of years. Planets in unstable orbits would have been ejected from the system long ago, leaving only those in stable, mathematically related orbits. What we see today might be the survivors, not the result of intelligent design. Even the apparent rarity of Earth-like conditions might be an illusion caused by observational bias. We've only been able to detect exoplanets for a few decades, and our methods are better at finding large planets in close orbits around their stars. We might simply not have found the Earth-like planets yet because they're harder to detect with current technology. Despite these natural explanations, the search for evidence of artificial solar system arrangement continues to yield intriguing results. Recent discoveries have only deepened the mystery. In 2016, astronomers discovered what they're calling Planet 9, a hypothetical ninth planet in the outer reaches of our solar system. What's strange is that the orbits of several distant objects seem to be influenced by something massive that we can't see. The gravitational effects suggest a planet about 10 times the mass of Earth, but it's so far away and so faint that we haven't been able to spot it directly. Here's what's interesting. The proposed orbit of Planet 9 is almost perfectly designed to explain several puzzling features of our outer solar system. It would account for the unusual clustering of certain asteroid orbits, the strange tilting of some planets relative to the Sun's equator, and several other anomalies that have long puzzled astronomers. Some researchers wonder, could Planet 9 be artificial? Could it be a massive object placed in precisely the right position to fine-tune the gravitational dynamics of our solar system? The fact that we can detect its effects, but not the object itself, is certainly curious. Then there's the ongoing mystery of Saturn's moon, Enceladus. This small, icy moon has geysers of water erupting from its surface, suggesting a liquid ocean beneath the Icean Ocean that might harbor life. But what's powering this activity? Enceladus is too small and too far from the Sun to maintain liquid water through any known natural process. Some researchers have proposed that Enceladus might contain artificial heating elements, some kind of technology designed to maintain conditions suitable for life. It sounds far-fetched, but so far, no natural explanation fully accounts for what we observe. You know, as I've been researching this topic, diving deep into the scientific literature and exploring these mind-bending possibilities, I find myself experiencing a strange mix of wonder and unease. On one hand, there's something almost comforting about the idea that our solar system might be designed. It would mean that life isn't just a cosmic accident, that somewhere out there, there's an intelligence vast and benevolent enough to create this perfect cradle for life to evolve and flourish. We wouldn't be alone in an indifferent universe, but rather cherished subjects in the greatest experiment ever conceived. But on the other hand, there's something deeply unsettling about the possibility that everything we think we know about our origins and our destiny might be an illusion. Are we truly free agents charting our own course through the cosmos, or are we lab rats in a maze so vast we can't even see the walls? I think what strikes me most is how the evidence forces us to confront the limitations of human understanding. Whether our solar system is natural or artificial, the precision and complexity of it all is so far beyond anything we could ever hope to create or fully comprehend. It humbles you, you know? It makes you realize that we're probably not as smart as we think we are. And yet, the very fact that we can even ask these questions, that we can look up at the stars and wonder about our place in the cosmic order, suggests something remarkable about human consciousness. We might be the subjects of some vast experiment, but we're subjects capable of recognizing that we're being studied. That has to count for something. Where do we go from here? How do we get to the bottom of this mystery? The next few decades are likely to be crucial. We're developing new technologies that will allow us to study our solar system and others with unprecedented precision. The James Webb Space Telescope is already revolutionizing our understanding of exoplanets and solar system formation. Future missions to Europa, Enceladus, and other potentially habitable worlds might reveal evidence of artificial intervention. We're also developing more sophisticated models of solar system formation that will help us understand what's normal and what's unusual about our cosmic neighborhood. If our solar system really is as rare as it appears to be, that might be evidence in favor of artificial arrangement. Perhaps most importantly, we're beginning to develop the computational power necessary to simulate entire solar systems and study how they evolve over billions of years. These simulations might reveal the signatures of artificial intervention patterns or behaviors that could only result from intelligent design. There's also the possibility that we might receive direct communication from our cosmic experimenters. If we are part of an ongoing study, there might come a point where contact becomes appropriate or necessary. The recent increase in official government acknowledgement of UFO encounters makes me wonder if we're already receiving subtle messages that we're not yet sophisticated enough to understand. As we reach the end of our exploration today, I find myself more convinced than ever that we're dealing with one of the greatest mysteries in human experience. Whether our solar system is a natural wonder or an artificial construction, the precision and beauty of it all is absolutely breathtaking. The mathematical elegance of planetary orbits, the perfect positioning of our protective Jupiter shield, the incredible fine-tuning that allows life to exist on Earth, it all points to something greater than random chance. Whether that something is the hand of cosmic intelligence or the deep mathematical structure of reality itself, we're clearly part of something magnificent. But here's what I want you to take away from all of this. The mystery itself is valuable. The fact that we can look up at the stars and wonder about our origins, that we can use our intelligence to probe the deepest questions of existence, that we can imagine possibilities beyond our current understanding, that's what makes us human. Whether we're alone in the universe or part of some vast experiment, whether our solar system is natural or artificial, we're here, we're conscious, and we're capable of asking these profound questions. In a universe that might be indifferent to our existence, or in a cosmic laboratory where we're the subjects of study, the very act of wondering about our place in it all is an assertion of our humanity. Maybe that's the real purpose of the experiment, if there is one. Not to study our technology or our social development, but to observe the emergence of consciousness capable of contemplating its own existence and questioning the nature of reality itself. And perhaps, just perhaps, when we reach a certain level of understanding, when we've grown sufficiently in wisdom and knowledge, we'll be ready for the next phase of whatever cosmic plan we're part of. Maybe the experiment isn't about studying us from a distance forever, but about preparing us to join the community of cosmic intelligences, to become experimenters ourselves. Until then, we keep looking up, we keep asking questions, and we keep pushing the boundaries of human knowledge and understanding. Because whether we're products of chance or design, whether we're alone or observed, the quest for truth and meaning is what defines us as a species. What do you think? Are we living in a carefully designed cosmic laboratory, or are we the products of an incredibly fortunate series of accidents? Have you ever looked up at the night sky and felt that sense of wonder mixed with unease? That feeling that maybe we're part of something much bigger than we understand? I want to hear your thoughts. Drop a comment below and let me know. Do you think our solar system shows signs of artificial arrangement? What evidence would convince you one way or the other? And if we are part of some cosmic experiment, what do you think the experimenters are trying to learn about us? If this kind of deep dive into cosmic mysteries resonates with you, make sure to subscribe to Javis Heist and hit that notification bell. We've got more mind-bending explorations coming up, including investigations into time anomalies, consciousness mysteries, and other phenomena that challenge everything we think we know about reality. Remember, the universe is vast, mysterious, and full of wonders we're only beginning to understand. Stay curious, keep questioning, and never stop looking up at the stars with wonder. Because whether we're alone or part of something greater, the journey of discovery is what makes us truly human. Thanks for joining me on this cosmic journey, and I'll see you next time here on Javis Heist, where we explore the mysteries that matter.